Hello everyone, or bonjour, or konnichiwa. My name is Hideki Takase, an associate professor at the University of Tokyo in Japan. And Shintaro Hosowa is a project researcher in my laboratory, and he is my best research partner. Thank you so much for inviting me as a presenter at the Zenoh User Meeting 2023. But unfortunately, this event is going to be held at midnight in Japan. So please allow me to present this video recording. Our talk title is Zenoh meets Elixir in Japan. We hope you enjoy our talk as one of the examples of research activity for Zenoh. Before talking about Zenoh, let me talk about robot operating system. We have already established some achievements for the growth of ROS ecosystem. One of the successful projects so far is MROS2, the integration of embedded technology into ROS2. However, we don't have enough time to share this activity in this presentation. So please check our video archive at ROSCON 2022, held in Kyoto, Japan. Second project is RCLEX, a new client library for the functional language Elixir. I will introduce this achievement as the first topic. During this research, we met Zenoh. And then we decided right away to adapt it for our research project because Zenoh has a perfect feature to meet our requirements. We will also share this later. Finally, I will introduce the ongoing activity. Can you imagine that what happens when Zenoh meets Elixir? Okay, let's go to the first topic. As we know, ROS2 has an awesome software structure. The most important component in ROS2 is DDS. The RMW layer is on top of the DDS layer. We can choose a suitable DDS implementation by changing this layer. And of course, we were too surprised and excited when ROS2 TSC announced that Zenoh would be a new target for RMW support. But please focus on RCL layer for now. ROS client library provides common features for ROS2. This layer is implemented in C, so we can implement a client library for any programming language by calling this C layer. So what we need is RCLEX. RCLEX will bring the power of ROS into the Elixir application. And more, we can implement ROS node with Elixir by functional paradigm. By the way, do you know Elixir? I think Elixir is not very famous in ROS and Zenoh community. Elixir is a functional programming language operated on ARM virtual machine. And ARM has been developed by Ericsson from 1986. One of the key features is that the processes in ARM is very lightweight and robust. Moreover, since ARM has been developed for telecommunication and server systems, it has excellent concurrency and parallel performance with soft real-time capability. So we can construct distributed and fault-tolerant system in ARM. Elixir inherits all these advantages of ARM. In addition, Elixir and ARM are very similar to the actor model. In the actor model, actors send and receive messages in parallel to realize concurrent processing. All messages are going to be exchanged asynchronously. Since the actors are communicated only through the message, we can also realize loosely coupled systems with ARM and Elixir. In addition to features inherited from ARM, the notation and specification of Elixir is designed based on Ruby. So the notation of Elixir is easy to run, and the productivity of application becomes very high despite functional. This is one of the example code in Elixir. This code generates a list from 1 to 1000, distributed the list element to each core, applies the function foo and bar to each element, and finally returns the result to the sorted list. I think programming should be about transforming data. I'm happy if you agree that Data flow and parallel processing can be described directly by Elixir. Furthermore, Elixir already has a strong ecosystem with many libraries and frameworks. Phoenix for a web framework, Nerves for IoT application, Ect for database management, and NX for AI ML application. This means that we have the perfect environment to start developing IoT systems in Elixir. And more, we want to integrate the power of RCLX into Nerves platform. Nerves is a dedicated platform for IoT devices developed and maintained by Nerves project core team. Nerves offers fully compatible features with Elixir. And also, Nerves provides useful libraries suitable for IoT systems. There are two important points for Nerves platform: bare minimum and resilient. Bare minimum means that the firmware of Nerves is too small, around 30 megabytes. The Nerves compiler links the embedded Linux kernel, libraries, and application code together as one firmware. Resilient means that the Nerves platform is robust and reliable. Of course, we can realize highly robust systems with the power of ARM. Moreover, Nerves firmware has a unique file system structure consisting of duplicated regions. The kernel and applications run on one file system site, but if a failure occurs there, we can migrate to the other file system and continue the operation. Here is a list of supported target ports. We confirm the operation on RCLEX on Nerves so far. And this table shows the support of loss distribution for RCLEX on Nerves. Raspberry Pi 4 with Humble is the best to try it out. We also support AMD Xilinx Clear KR260 boards, BeagleBone boards, STM32 MP1, and ERT3 Plus. Now, I want to show the demonstration of RCLEX on Nerves. We use Raspberry Pi Mouse V3 as a mobile robot. RCLEX on Nerves is installed on the Raspberry Pi 4 mounted on the robot. The USB camera is also mounted on the Raspberry Pi Mouse. We know that we can control the robot by publishing the CMD bell topic from joypad, and we can also subscribe sensors on Ubuntu Roast laptop. But this alone would not be interesting for RCLEX on Nerves. Yes, let's integrate the power of the Elixir ecosystem. We also implemented Phoenix Live View web server to monitor sensor data via HTTP access. This is a recording of demonstration. The left side is a robot's actual behavior captured by the laptop camera. And the right side is a Phoenix Live View web page operated on the robot. We can confirm the sensor value easily by such a web page. And also, please imagine that such IoT applications can be easily realized with the magic of Elixir ecosystem. By the way, what do we really want to realize in our project? We want to connect any nodes in widely distributed environments easily. Please imagine that two computers are in same network and they know each other's IPs. In this case, Elixir offers Node Connect feature to connect them in the network. Node Connect is very useful, but we always specify node name and IP address to each computer. But please consider the case where you don't know the computer's IP address in the network. How can we connect with such a node without its IP? Actually, our RCLEX can resolve this situation. However, in the next case, we consider connecting a node on a computer in another network. If the computer has a global IP address such as server, Node Connect works fine to connect them. Also, Node B1 can connect with Node B0 because they are in the same network. However, do you think node A1 and node B1 could connect as a nodes? The answer is no. We could not connect them because RCLEX and DDS have a limitation about NAPT server. The final concern we want to realize is communication with node A3 and node B3. These computers are on different networks, and of course they don't know each other's IP address. In such a situation, we want these nodes to communicate easily. Yes, we have RCLEX for the same network and Zenoh for the different network. Zenoh is a perfect solution to meet our requirement. So we try to integrate the power of Zenoh into our RCLEX on NAPS platform. We came across Zenoh around June 2022, and then ROSCON 22 happened in October. We found the ZettaScale booth and we could meet Julien and many of the folks and got to know Zenoh deeply. Zenoh can construct any topologies, is extensive to other protocols, runs everywhere, and there is a plugin for DDS. And 2 weeks after ROSCON, we had a plan to present RCLEX at CodeBeam America, one of the famous conferences in the Elixir and Erlang community. We decided to try Zenoh for our project. In just 2 weeks, we have established a way to integrate Zenoh into RCLEX. Just 2 weeks. Amazing. Well, the solution to how to use Zenoh with RCLEX on NAPS is summarized in our repository. Since Zenoh is implemented only in Rust, both routers and clients can run only in statically linked binary. To run Zenoh's bridge for DDS on a computer, we simply specify the router's IP and port number as arguments and run it in the background. To operate this on NAPS, we turn to use of Moontrap approach. This is one of the features in NAPS to allocate the executable to be run as a daemon. Please watch the video recording of a live demo at CodeBeam America. The entire presentation is available on YouTube.
Now, these two computers can connect each other, and joystick value, I can control the behavior of turtle by joystick value. This is the first demonstration. And for the second demonstration, Zenoh is app for grabs. We have a Zenoh router running in a VM deployed on Azure. I will control the turtle nodes running in Japan by using the Zenoh DDS plugin. This means that RCLEX message between nodes will go beyond the Pacific Ocean. So it's time to demonstration. I want to introduce Shintaro. He's a project researcher in my laboratory. So what time in Japan?
Okay, good morning, everyone. I'm joining from Japan. Okay, I share my screen. Okay.
Maybe Japan is around 8 a.m. So I guess he may be a little angry to help with this demonstration so early in this morning. So please share your screen, okay? I got it? Yes. And there are 3 terminals. In the first terminal, he is connecting to Azure VM and launching the Zenoh router. And in the second terminal, Shintaro is running Zenoh DDS plugin on his laptop. Of course, I don't know the IP address of his laptop. Now, please bring up the TurtleSim node on your laptop. Okay. I execute two commands again and operate the joystick. Can you hear? Can you see? Oh, okay. RCLEX message go beyond the Pacific Ocean now. Thank you very much.
Okay, thank you for watching. We can now confirm using Zenoh along with ROS2 DDS and Elixir. But please remember that Zenoh runs everywhere because there are native libraries and API bindings for many programming languages. Oh wait, why is there no Elixir? The answer is yes, we can. Here is our latest activity to establish the marriage between Zenoh and Elixir. We are now working on the development of Zenoh EX, Elixir API for Zenoh. Key idea to realize Zenoh EX is very simple. Elixir and Run provide a nifs feature that can call the function implemented by other languages. We use Rustler as a nifs feature. Rustler is a famous library to call Rust function from RunVM. It can call Zenoh APIs and convert Run and Rust resources to each other. Of course, our source code is published on GitHub. Please check it out. Now, it's demonstration time for Zenoh EX. Create a new Elixir project and add Zenoh EX library in it. The left side is a subscriber code. This node will create a session to subscribe the topic and then execute callback function. The right side is a publisher code. This node also creates a session and publishes a string message repeatedly every 1000 milliseconds. Now we will restart both nodes. Subscriber and publisher. Yes, we can confirm that these Elixir nodes can communicate by Zenoh protocol. Of course, Elixir nodes can communicate with native Zenoh nodes implemented in Rust. Please understand that Zenoh EX is still in an early stage of development. Supported feature is very limited and there are many works to tackle. We would be happy to receive contributions from you. Just FYI, I wanna share two upcoming events. First, we will present Zenoh EX at CodeBeam America, which will be held next March. In order to make Zenoh more widely available to the Elixir and Run community, we should work hard to improve Zenoh EX features by the time of this conference. And one more thing, we are very happy to welcome Angelo in Japan. If you are also in Japan next week, please join us for this meetup. Please find my account Takase Hideki on X, GitHub, and Discord server for Zenoh. and feel free to contact me to ask anything and give your advice on our research topic. Finally, thank you very much for watching my presentation. Merci beaucoup, or in Japanese, ありがとうございました。